Okay, so I have yet another Xbox board. This one, let's see, let's set it right here. This one is the original one, the one that was from, or my family's, that was from 2013. This one's also 2013. It's just this one's a little newer than this one in month. But basically what happened is I had, long story short, or I'll try to keep it short, but basically I was trying to diagnose why my board wasn't booting up. I was super confused. I ended up burning one of these MOSFETs right here, which on their board looks like, let's see, pointing, something a point. I ended up burning this guy right here, so it would short out and just go straight to ground, and this guy would also go straight to ground, so they just shorted out. And so what I ended up doing is I tried replacing both those pieces, tried several different things, but eventually I realized that the reason why he wasn't booting up in the first place, I left, as dumb as it sounds, I left this trace undone. And this trace is like the eFuse read, I think is what it is. Something like that. I don't know. It's not very descriptive. But it's just something I found in the video. But this little trace right here is supposed to, it's like really dirty because I soldered it a ton of times. So let me just clean it up. Well, basically it goes from that to there. But I cut it with X-Acto knife right where this end is, and so I had forgotten to connect it with just a solder ball or something. So because of that, this one's gone now. So I got another one, and this one, what I'm gonna do is I'm probably not gonna remove any of the MB core stuff because I don't even think you need to do that. I think that was just for trying to find the timing onto when to do the glitch. But basically I found, or no, I found, but someone else did. It was this guy, apparently made respiratory for the glitch hack, and it's very descriptive. It does kind of look like it's made by AI because the emojis and stuff, I don't know. Like, well, why would you need a what's inside explanation in your README? Anyways, but basically this has everything you need to do it except for the physical things. So it says you need a Xbox One Fat. I already have that. It needs a TNZ 4.1, which is the main controller. I don't have one of those. A high-speed N-channel MOSFET. So they are using a or it's suggested IRLU 0424N or similar. That shorts MB core during the glitch. And a bidirectional shifter. I also don't have one of those. Converts the 1.8 eMMC bus to 3.3 volts that the TNZ can understand or actually read. A 0.1 ohm shunt resistor through hole SMD to sense the eFuse voltage dip, and a 10K resistor to pull up for the eFuse line if needed. So the one problem I'm noticing is that, well, before I get to that, I actually used AI to convert this code that was listed here. So the Arduino Uno code, or Arduino IDE code, and took it, pasted into AI, had it convert all of this, which is for the TNZ board, and I converted it into, let's see, I should just open up. Yeah, this guy right here, Arduino IDE. Why is it so, I don't want it to be this big. Why is it taking forever to Okay, so I ended up converting into this, made some adjustments and stuff. Like I said, I have very, very little knowledge with coding, but I have enough to understand some things. Like, for example, I made this horrible. People who know how to code probably would call this unnecessary. Like, why? You could probably just make a loop for this. I don't know. But I used AI to help convert that code into something that would work with my ESP32. I also took the delays that were for the teensy and converted them into delays that would work at the same time for the ESP32 that I have, because the teensy is like a 600 megahertz clock speed, while the ESP32, wherever I put it, somewhere around here. Oh, it's right here. Okay. The ESP32 that I have is only 24 megahertz. So, and I also had to figure out what pins to map the eMMC to, because some of the pins, which is why I have this, some of the pins would interact with like how the ESP32 connects to the USB port through this guy. So basically what I'm working on right now is trying to figure out how to enable this glitch, because I noticed that I still, like in the original code it says to use eFuse pin. It's not very descriptive of where that eFuse is or where to attach it. Like, I'll show you. So it says right here, solder a thick, no wait, that's the wrong one. It says solder the 0.1 shunt resistor or ohm shunt resistor in series with the eFuse 1.8 rail. Cut the trace or lift the pin. It says like you don't need to do any of that like you did in the video. It just says to solder one side to the rail and solder wire from their side of the shunt to the teensy pin, or what I have on mine. And it says it can add a pull up 3.3 if the signal is too weak, but in our logs it worked with that. So I've been trying to measure this eFuse rail, but I don't exactly know if I'm even looking at the right thing. So if I go here, let's see, Control F, so I can search, zoom out a little bit. Okay. If I go here, type in or search for eFuse. No matches. What do you? Oh, that's the wrong thing. vFuse is what's called in the data sheet, or just fuse. And so, see, it's mentioned like that. So, if I just scroll through the search, eventually you come to this rail right here. So you can zoom in a little bit. It's hard holding one hand for the camera and one for the computer. See, so this guy right here, this is only 0.95 volts, and so I'm like, okay, pretty sure that's what he's referencing in the video. I don't know for sure, but I have the screenshots from the video that I saved just because I didn't have to rewind the video hundreds of times. And see, he said he was able to read the, if we can find it first, somewhere around here. I think it's this one. Yeah, it is. It's hard to see. So this guy is what he was able to read after he cut that trace and installed that shunt resistor between it. And so he has this, and it looks like he measured it for the first dip, but right here it's like 100 or negative 100 or 123 millivolts dip. So it goes from however much volts this is to 123 millivolts less than that. So I don't really know if I'm even reading the right thing, because in the video where I have like tons of screenshots of like just random pictures he showed in the video, but like even with this picture, I think this one was taken around the same time. This one's the blue, this one's the red. And I would assume he connected up the first, or let's see, the green one, which is the last one, to the well, I don't know. So basically, another thing I'm trying to look for is the South Bridge interrupt, because I think I might have found it. I have it connected right now. At the moment, it's not actually on though. But I was able to find a spot where I see this like drop in voltage, and then it spikes up once, then keeps going, and then spikes up. But for me, it drops in voltage, spikes up once, keeps going, and just keeps going for a little bit, and spikes up multiple times more, and then eventually goes up to 1, or however many volts that was. And when I compared it to the power OK signal that I had on my board, it was around the same time that this happened in the screenshot. So, except for it didn't pop back up like this, it just stayed down and fluctuated more times. So I don't know what's different about the one he had compared to the one I have. But yeah, that's what I'm trying to figure out right now. So if I actually shorten this guy, because I know people were saying that, and AI were like lots of different references saying that you should have the wires as short as possible. So I soldered it straight onto the board, and then just made a little mount for this guy to lean against, so it's ground and positive pressed up against it on its own weight. And this guy was just reading random different points, like the that one voltage spike thing. And so that I don't care too much, because we aren't like trying to get a super fine measurement of voltage. So if I actually, let's move this over here. If I take this guy, plug it in, oops, upside down, okay, plug it in, you'll see it. The purple one is this guy, which is connected to that one, the one spike thing that like goes down, spikes once, then keeps going. And this one is the yellow, which is the E-fuse read, supposedly. So if I plug it in, see it spikes down once right after the E-fuse enables. Stop this, unplug the Xbox. Okay, so if I zoom in on this, do this, see, go to, I can't see it because how zoomed out I was, but there's supposed to be a spike right there. I'm pretty sure it's just not visible because how short in time it was and how many samples my oscilloscope was taking at a time. But yeah, I'm just kind of lost to what to do. So let's see, if I go back here to screenshots, it looks like that stock power okay, and that's like in a 500 microsecond of a difference. This is like way more than a microsecond. This is like milliseconds of difference. Huh. Okay, so, but yeah, okay. So I think what I'm gonna do next is I'm gonna, instead of using trying to check the E-fuse read first, I'm just gonna take the E-fuse off, read sock power okay, see how far apart that is from this guy, and then see what I can do about that, and then take that information and see if it's any better than this, or if I can find where the E-fuse read actually like dips with this. The thing is, I tried different ways of trying to find, and I just don't see a dip. Like I don't see a dip in E-fuse reads at all for some reason whatsoever. So I don't know what to do about that, but let's see. So I'm just gonna change it up real fast, so I'll be right back. Okay, so got it hooked up to the power OK signal. Got it hooked up to this guy, which is channel 1, so yellow. So I have it trigger right on the rise of that. So it rises up, then right here you see it, the Southbridge interrupt, which I'm pretty sure, I know for a fact it would have to be that by now, because it drops down, has a little spike thing, keeps going. This one, it does come back up for some reason, but I think it varies a little bit though, because yeah, if I take this, then let's see if I can hold the phone and do this all at the same time. Oh, let's not do that. I don't want to. This guy's short out or something. Okay, now let's try this. So if I plug this in quickly, press signal, boom. Yeah, that time it didn't even have the spike. That's weird. Okay, now let's try it again. See how much it varies. Yeah, see, that time it actually closed off though. Huh. Let's try again. Yeah, see, now it's back to the way it was. Huh. Yeah, I don't know. It's kind of interesting. But, I think if I take that, because that seems to always happen right when, or he was using that as a trigger point for finding the MB core initiate part. So I think what I'm going to do is I'm going to connect this guy up to here. Well, I don't know, maybe I'll try to see if I can get the trigger to trigger on this first rise after the initial one. I think I might be able to do that. Okay, well, I'm gonna try that out real fast. Okay, so I got the trigger on that little pulse. So now if I take it to like 2 milliseconds normal, and because that pulse doesn't always happen, I'm starting to notice it won't always trigger, so I have to like attempt a couple times. Nope, didn't happen that time. Turn it off. Try again. Nope, that's just noise. Okay, try again. Nope, also not what I'm looking for. Okay, so let's see. Let's try again. Nope, that's just noise. Okay, wait, I'm gonna raise this up a little bit. That might help a little bit. Okay. So much cords in the way. Okay, let's try this again. Okay. There we go. Okay, much better. Okay, so if I zoom in on this, it's definitely there. So, oh, look at that. It actually like went up that time. Huh. Okay, so now I'm going to take this. I'm going to put the yellow one on MB core and see if I can find anything like that. Okay, so I mounted it just so it's like that and as short as possible. Powered it on and did a little bit of diagnosing, and well, I have it set to roll right now, but it triggers right there, right where the whole thing goes up. So actually, if I just take this off roll, get back to like what it was on in the video, single, plug it in. Whoops, it's off by a little bit. Let's change that back. Okay. It's really noisy for some reason, too. Oh, it's probably because I'm touching it with my thumb, or touching ground with my thumb. Let me try that again. Okay. Let's try this. There we go. A little better. Okay. So you see right where that spike happens. It's like right where it goes up. So I don't know why that looks different, but oh, maybe it's a voltage reversed or something. I don't know. Well, yeah, I'll update you guys on next video, but for now this is where I'm at. I'll keep doing stuff, and yeah, see ya.